Today we're going to talk about how to install the EZ2209 on the BigTreeTech SKR version 3 EZ. Now there's a couple of things we need to understand. This is the actual stepper driver right here, which has an encapsulated cooling system around it so that it wicks away the heat with cooling fins on either side. And it also can only go in one direction, so this label needs to point towards the power supply when it's installed in either your X stepper, your Y stepper, your Z stepper, your E0 stepper, or your E1 stepper. Now, because we're going to do sensorless homing today, we need to place a jumper, which I've already pre-placed down in here, so that we can do sensorless homing. It's left blank here, 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 and here, which you might not be able to see too well because it's very tiny, but I'll point out what the actual jumper cap looks like down here so that you understand how to use it. Now we're going to be using the default PSU power supply for our power instead of the power that we could use of either 12 or 48 volts for a range of power. We're not going to be using this, but if you were to use this power supply with a higher power, you would need to move the jumper that's down here over to the other two sets of pins in order to enable that. But most people are not going to be running 48 volts, so I'm not going to talk about that at this time. But I am going to talk about how to install a cooling fan system. So I have a 24 volt fan here that I'm going to be using off the 24 volt power supply. And we're going to use the signal pins off our fans down in here in order to configure this. So let me set this up real quick. So in order to install the fan, we're going to plug it in right here. So the next thing we need to do is actually install our stepper, which already has the jumper for sensorless homing. So we'll place this in here and make sure that it's fully seated. Next, we're going to grab the actual cable for the X-axis, and we're going to plug that in so that we can run on this rail. Next, we need to install our power supply, and as you've seen in the previous tutorials, I've actually marked where the ground and the voltage go for our power supply so that we can do this without too much of an issue. So I'm going to pick this up and I'm going to slide this in. Notice how I'm using ferrules. This allows us to keep the wires encapsulated to reduce the errors that can occur. I'm going to slide this one in and tighten it down. And those should be nice and secure. So we've got everything configured. We're not going to use the USB power for our USB connection here, so it will not power up. The reason that we're doing that is because if we connect the jumper for USB over here, when using the actual steppers, it will cause an actual reset on the steppers, which we don't want. So that's why that's not going to be connected for this particular tutorial. So I'm going to pop this out, and I'm going to find where I dropped it. I'm actually going to grab some tweezers. By the way, you can use these tweezers to install your actual tiny stepper right here inside of here, because your fingers can't easily get in there. So now that we have that set and the board's all configured, we're going to have to load the firmware. So we're going to have to build it in a second. So I'm going to install this inside of here and plug this into the computer, so you may hear a beep. And then we're going to go over to VS Code on our desktop. So I'm going to click on the Explorer. I've already downloaded and extracted Marlin 2.1 from their website. So I'm going to go in the first Marlin folder, the second Marlin folder, then select folder. Inside here, I'm going to go to the Marlin folder, the source folder, the core folder, and boards.h. I'm going to then search on SKR_B3, and that'll bring us to the actual board type that we need. So I'll copy that. Then what I'll do is minimize source and core, and then go over to configuration.h and search on motherboard. Now, as you can see right here, we have the motherboard, so we'll highlight that and we'll right click and we'll paste what we just copied. Now, back over here, I didn't point out that the actual board type, we actually know the chipset because it's currently in here. This may change in the future depending upon BigTreeTech, but currently it's the STM32H743VG. Now, that is the MCU or the big chip in the center of your board. So I'll point to this real quick so you can see it. So over here, your MCU actually has that label on it. So let's go back and finish up the actual configuration. So in order to set these steppers, we have to go back into configuration.h and search on A4988. This will bring us to the actual configuration for the stepper. In this case, we're using a TMC2209, which is the EZ2209. So we'll find it in the list over here, highlight it, copy it, and then paste it over the x-axis. So the next thing that we need to do is actually find, I believe it's steps per unit. So we'll do a Control F and search on steps per, and that'll bring us to here. Now inside here, these are the defaults that come with Marlin. It may vary depending upon if you do or do not use RepRap calculator to compute your axes, but you can also recompute them after doing a calibration print. So I'm then going to go to Configuration Advanced to show you the other half of this problem. So I'm going to search on 800. This may take a few actual searches to get us to the right place, but here is the actual configuration for our stepper. Note that it can be from 1/16 of a step to 256th of a step. So in this case, I'll show you how to configure this if you so desire. So if it's 80, you're going to be obviously defaulted to 16, but if you go to 160, that means you're going to have to change this proportionally to 32. So let me show you that again. If you change this to 360, or excuse me, 320, that means you have to change this to 64. So it's 1/64th of a step. Now I don't recommend going much higher than 128th of a step, but in this case, at least you now have the idea of how that is actually configured. Now to set up sensorless homing, we need to search on, let's see, TMC_debug. And the reason that we're searching on this is actually to set up driver monitor status. So we're going to hit Control / to enable this. And the reason we're doing this is because we want to use the G code to verify our configuration. So now that we have that actually known as the M122 command as a G code, we can now use this in the future. But we have to search again for TMC debug and enable this one as well. Now you can disable this after you know that your steppers are functional. So let's set up the sensorless homing. We're going to search on, with a Control F, sensorless _homing. And what we're going to need to do is enable this with the Control /. Then this will become enabled in a second. And essentially for TMC type steppers, the range of sensitivity is from 0 to 256. That means that the highest sensitivity is 255, and the lowest is 0. In this case, we're going to pick around the middle, which is 125. That normally works for everyone. There have been cases where people have made mods where it doesn't, but this is the number that works about 99% of the time. Now, the other thing that we need to do is set up the cooling fan. So what we're going to have to do is we're going to have to do a Control F and search on use underscore controller underscore fan. So we're going to have to enable this by doing a Control/. Now the issue that we're going to run into down here is that it's set to -1 and it's not enabled. So we'll do a Control/ to enable that as well. And then we have to actually give it a pin because -1 is no pin specified. So in order to do this, we need to know what the pins are. So if we go over to the web browser for a second and we click on the pins file for the SKR3, what we want to do is use the pin that's located right here for our signal pin. So that's going to be fan 0, fan 1, fan 2. So fan 2 in this case is PB5. Now we can confirm this as well inside of Marlin's firmware to make sure that we have it. So we can go to source, then we can go to pins, and we remember what our actual chipset is, which is the STM32H7. Then we can go to the common for the SKR. It will be broken out depending upon board or the board type down here, but currently this just points to the common file, which I showed you earlier, where all the pins are located. This probably is going to be exactly the same, but they do that in case they make some changes in the future. So inside of here, we're going to search on, with a Control F, PB5, and we're going to see what that says. And down here, what it says is that it's the spindle laser PWM. It also says that it's fan 2. So we know we have the right one according to what we see in here. So we'll go back over to here. We'll change the -1 to PB5 for the pin number. And then we'll have to set this up to actually build next. But there's one last thing I want to point out. If you go to home, your access, and it goes in the wrong direction, you can search on invert, and down in here you can actually change the direction at which your axis actually moves. So you can reverse it by changing the false to a true or the true to a false. So keep that in mind. And there's one other thing I just thought of, and that's voltage. So if you search on 12 volts, there is a section in here where you can set the power supply voltage. Now, as you can see, there's multiple types. It doesn't go all the way up to 48 volts, but currently we're using a 24 volt power supply. So if you decide to use something like Chopper, which I'm not showing you currently, then you would highlight here and you would actually paste it over this like your motherboard. So let me highlight this better by double clicking and then hitting Control V to paste. So let's go set up the actual environment to build now. So I'm going to minimize pins, source. I'm going to go over to Platform IO. We're going to have to change our default environment for our board type, not the ramps type. So that means we have to go over to the INI folder. We have to search for our board name, which is STM32H7. And as you can see right here, we have our board specified. So I'm going to highlight the environment, copy it, and then I'm going to go over to platformio.ini, paste it over the Mega 2560, and then we're set there. The other thing that we need to do that's good, healthy practice is to actually clean out your folder. So I'm going to click on the little garbage can down here, and that will clean out the last build that took place. Now I'm going to click on the actual build checkbox down here, and this might take a moment to actually build. After it completes, if it completes, we'll load the actual firmware.bin on our system. But just to remind you, If you get a failure on the first time you build, hit the checkbox for build a second time, just to make sure that something's not building out of order. If you get a third error where you see red in here like we're seeing right now, then that means we've got to fix something. And this is actually a good error to see because I forgot to show you something which most of you already know. So if we go in here and we search on motherboard, I forgot to set the actual serial port to -1. Now I'm setting the serial port for the actual printer board to -1, but it can also be set down here as well. I just do this because the first thing that I like to configure is the USB port. They're interchangeable, and there's actually 3 of these. So let's go back and try and build this again, because in this case the very first error is the one we want to fix. Anything else thereafter is a cascade of errors that are occurring. So the first one being fixed is a way to prevent that and possibly limit the number of things you need to fix. So we can actually watch this in the .pio folder and see what's occurring. So in a moment or two we'll see something like firmware.elf and then firmware.bin. It's going to take a second because it has to build related files in order to build the full build for the binary file. And when I say binary file, I mean ones and zeros. But it's something that the microprocessor can understand. So I'm not going to go too much into that because that's a completely different subject that most of you are not interested in. So you see the ELF, now you see the firmware.bin. So I'm going to right click on firmware.bin and say reveal in File Explorer, and we're going to double check that our previous build from last night, this was a successful load of firmware.bin. So we're going to go back and we're going to right click on firmware.bin and send this to the USB drive. Now you see them both here. If this is successful, it will be renamed to this. If you ever want to reload it, you would name it to this and then drop it back in, and it'll, if successful, be renamed to firmware.cur. So let's pop out the drive and install it on the board. So I'm going to plug this in over here. I'm going to do a pre-flight check of the board to make sure everything is solidly connected as best as it can be. Connect this up, and now I'm going to connect the power, which was disconnected the entire time. So this will flash the board and we'll hear a beep if it connects correctly, which it apparently seems it has. So the next thing that we're going to do is we're actually going to go over to Pronterface. So this might take a second to come up. We'll see what happens. There we go. As you can see right now, it says COM port 1. So we're going to need to find out what our COM port is. So I'm going to go to the workbench. Whoop, pardon me, not the workbench, to the desktop. And I'm going to click on Device Manager after I type it and press Enter. Now it may come up on a different screen like mine, but I dragged it over so you could see it. And inside of here you can see the STM Microelectronics Virtual COM port, and it's number 7. So in here, if it exists, we're all good. If it doesn't, you can highlight this and actually type it. Now the speed is correct, so we'll click Connect. It says the printer is now online. So let me bring it up so you can see this better. I'm going to type M122, hopefully in the right place, and then press Enter. And what this is going to do is tell us if things are okay or not. If it doesn't say okay, go back and follow the steps in the tutorial. That way you'll find the issue, hopefully. Normally, when you see low power, it means the power supply is not online. So you technically, in the way that I did the tutorial this time, it's not possible to see that without the jumper for the USB. That's why I showed it to you slightly differently this time. Now let's test the access. I'm going to move 10 millimeters to see if it's working. It appears to be working. Let's move back 20 again. Now let's try homing, which is going to be right here. And that appears to be working as well. So let's move ahead 100, then another 100. So it appears it's moving 200 millimeters. As you can see also, the fan down in here is actually functional. Whoops, I actually clicked into it, but now you know it's actually spinning. But we know that's working. So in order to see if it's not working, I'm going to click on the motors off. Now I set this to 60 seconds as the default, and I'll show you that real quick. Let me bring you over there so you can see what's occurring, but I'll click this first. So motors off means the motors are now disabled. But if we go over to the actual desktop and I click on the actual configuration for advanced and I search on use _ controller _ you can see that I did not change this setting here to less than 60 seconds. So in 60 seconds, the fan that would be cooling your actual steppers will go off. So at this point, I want to thank my patrons as well as the people on PayPal that have taken the time to donate to help make these possible. I will leave links in the description of the tutorial if you choose to if you choose to subscribe to Patreon. At least you get an advanced view of the tutorials, and also you help me offset the costs of making these tutorials for you. So everyone, thank you very much. Remember to like and subscribe, and take care.